So first one is this. Um, if the segment intercepted by the parabola y square is equal to 4ax with the line lx plus my plus n is equal to 0, subtends a right angle at the vertex, then which options are correct? Al plus n is equal to 0, 4am plus n is equal to 0, 4al plus n is equal to 0, and 4am minus n is equal to 0.
So like we can take 2 points on the parabola as at1 square 281 and at2 square 282, and vertex is 0, 0, right?
And right angle
Then
at
we
the
can
vertex.
like slope of OP to OQ, that should be -1. OP into OQ should be minus.
So you will get T1, T2 is equal to -4 from there. Right? Because this slope will come 2 by T1, this will be 2 by T2.
2 by 2, yeah.
So you'll get this condition. Now you have to ensure that you have to use some line stuff here. So this and this lie on
Both
the
the
line.
points are on the line, yeah.
So if you say that Lx plus My plus n is equal to 0 passes through a random general point, 80 square comma 280, right?
Right.
So then you will get LAT square plus m into 280 plus n is equal to 0, which is a quadratic in T, right?
Yeah.
This quadratic is supposed to have two roots,
2 roots.
which are T1 and T2. Correct?
Yeah.
So, and you know a condition on the roots. No? You know T1, T2 is -4.
-4, yeah.
So here, what are the product of the roots? T1, T2 here is
T2 will be
n by
n
AL.
by L. Yeah, AL.
N by AL is -4. So you will get
-4, then that's 4AL minus 4AL plus n is 0.
right. So that's
Yeah.
the way you do this one. Then let's see. Uh, vertex of a parabola is 3 comma 2 and directrix is x minus y plus 1 is equal to 0. Find the equation of the latest rectangle.
Oh, can you say the directrix and latest rectum is parallel and then have the same equation but not one, just some constant?
They will be parallel, right?
So can you write it as x minus y plus some c?
Yeah, obviously. If they are parallel, then you can write it like that. This focus is 3,2.
Oh, and the focus is midpoint.
Vertex is given. Yeah, vertex is 3,2.
Yeah, vertex midpoint. Yeah.
So this line will be x minus y plus c. And this will be midpoint, right?
Yeah.
You have to somehow figure out how to use that.
Right.
Slope here is -1 by -1. So this slope is +1, right? So this slope is -1, right?
Right.
Correct. And distance, you can find the distance from 3,2 to this, right?
Correct.
So
Yeah.
that distance can be easily found by dropping a perpendicular, right? And
Yeah.
then you have to say that, can you find foot of the perpendicular having same distance on this, right?
Correct.
So once you have foot of the perpendicular here, then you can find C, right?
Yeah. Yeah.
So 3,2 distance to this would be 3 minus
Yeah.
2
So
plus 1 by
3 minus
√2.
root of 1 plus 1. Yeah.
This is coming out to be √2 only, right?
Root. Yeah.
This distance is √2 basically. And this distance is also √2 then, right?
Correct. And we
So
can put that as 3 minus 2 plus c by root 2, right?
3 minus 2 plus c by √2. What are you saying?
Like we can
Oh,
do the
like that.
same
Yeah, like that also you can
same
say.
formula for that.
Yeah. √2 is equal to √2. You will get 2 and you will get 1 plus c. So c can be 1, which is not possible. Or mod 1 plus c is equal to 2. So 1 plus c is equal to -2 is another option, right? C is
C is
-3.
-3.
So you get x minus y is equal to +3, right?
Yeah.
That is your answer. You understood, no?
Yeah.
Right. Then locus of point of intersection of normals drawn at endpoints of focal chord of a parabola y square is equal to 4ax. You have to find the locus of point of intersection of normals drawn at the endpoints of a focal chord. So again, some theory that we discussed that we need to know about focal chords, for example, right?
Focal chord T1, T2 is -1.
And intersection points of normals A T1 square plus T2 square plus T1 T2 plus 2, comma, minus A
and minus a T1 T2
T1
into
plus
T1
T2.
plus T2.
This is your H and K, right? Locus.
Yeah.
Now use T1
Then
T2
you
is
can just
minus
put
1 here.
T1 T2.
So it will be A T1 square minus 1 by T2 is minus 1 by T1. So plus 1 by T1 square. And this is minus 1 plus 2. So plus 1, right?
Yeah.
And here it will be T1 T2 minus 1. So plus A T1 minus 1 by T1, right?
Right.
Now it is easy. You can just say K by A is equal to this, right? K by A
Right.
is T1 minus 1 by T1. H by A is equal to T1 square plus 1 by T1 square
T1
plus
square
1.
plus.
So that is K by A whole square would be T1 square plus 1 by T1 square minus 2. So plus 3, right?
Plus 3. Yeah.
So you'll get H by A is equal to K square by A square plus 3. So multiplying by A square on both sides, AX is equal to Y square plus 3A square. Y
3a
square is
square.
equal
Yeah.
to A common X minus 3A.
Right.
Correct.
Yeah.
So
Yeah.
that, so again, we are just using the results that we know, intersection point of normals, focal chord, right?
Yeah.
Uh, then let's look at this one. Uh, a tangent is drawn at any point P, on y square is equal to 8x, and on it is taken a point q alpha comma beta, from which pair of tangents qa and qb are drawn to the circle x square plus y square is equal to 4. So there are two parts to this question. Now first part is locus of point of concurrency, of the chord of contact AB of the circle x square plus y square is equal to 4 is what? This is the first part. So first think about what is he meaning by locus of point of concurrency.
Mhm.
That has to be clear first. Point of concurrency means when lines intersect, right?
Yeah.
So chord of contact is a single line, right?
Single line. Yeah.
But it is possible that chord of contact has many different points depending on where you choose Q, right? Many different types of chords of contact, right?
Correct.
So depending on Q, you will get different pairs of tangents which will have different chords of contact.
Different chords of contact. Yeah.
And those chords of contact could intersect at some point. That is the locus of that point of concurrency.
Oh,
Right?
okay. Mhm.
So try to think about what you will do here. This is the figure roughly. This is a parabola. P is a point on it. You have drawn a tangent. Q is an arbitrary point on the tangent. And from Q, you are drawing pairs of tangents to a circle, which is x square plus y square is equal to 4, right?
Yeah.
And equation of AB is chord of contact with respect to Q for the circle, right?
Correct.
Okay.
Chord of contact equation we can write as
T is
x into
equal to 0.
alpha plus y into beta is equal. Yeah, y into beta is equal to 0.
Chord of contact equation is x alpha plus y beta is equal to 4. And tangent equation from a random point, let's say here a is 2, right? So a is 2, so it is 2t square comma 4t, right?
40, yeah.
So tangent equation is ty is equal to x plus at square. So ty is equal to x plus at square,
2t square.
right?
Yeah,
This is tangent. So we know that q lies on this,
correct.
right? So
Hmm.
okay, so think about it, alpha comma beta lies on it. So if you put beta in this, right? So T
Hmm.
beta is equal to alpha plus 2 beta square, right? Correct.
And e2 beta square, e2 t square.
2t square, right? Correct. So alpha is coming out to be T beta minus 2t square, right?
Yeah,
So instead of using alpha comma beta here, I can use only one variable and say alpha is this, right?
right.
I can say x into t beta minus 2t square plus y into beta is equal to 4, right?
Yeah.
is my chord of contact, right?
Yeah. Chord of
Basically, I have
contact.
used the tangent part and I have put it in the chord of contact, right?
Correct.
Now, if you see here, this is the equation of a family of lines. If you look closely, you rearrange it a little bit, take beta common, right?
Mhm.
So if you take beta common, you'll get tx plus y, and this side you will get minus 4 minus 2t square plus x, right? 2t square x
Mhm.
is equal to 0, right?
Yeah.
Correct. So
Correct.
this is a line, this is a line, right?
Yeah.
This is like S1 plus lambda S2,
S2. Yeah.
right? Because you can just rearrange it and make it, this one is plus S1 and this is minus beta and stuff, right?
Yeah.
This is like a family of lines. So this is a line, this is a line.
Correct.
So they will always pass through a fixed point, right?
Yeah. An
It will be
intersection.
the intersection of this S1 and this S2, right?
Yeah.
So you can say that x will be equal to minus 4 by 2t square, so minus 2 by t square, and put it here. So you will get t into minus 2 by t square. So minus 2 by t plus y is 0. So y is equal to 2 by t, right?
Is equal to 2 by t.
Correct.
Yeah. Yeah.
You're getting minus 2 by t square and 2 by t always lies on chord of contact, right?
Yeah.
So that is your point of concurrency. And now you can
Correct.
find the locus easily, right? Locus will come as a parabola.
Okay.
H and K you can put and you'll
Mhm.
get the locus, right?
Right. Right. Yeah.
So how did we do this? The main idea here was chord of contact equation we have, but if we use two variables there, we can't do much. X alpha plus y beta is equal to 4 doesn't help us much because like we have to find a family of chords of contact, no, somehow.
Yeah. Yeah.
Only then can you find locus or point of intersections. So basically the point is to write chord of contact equation in such a way that you get a family of lines. So for that we use the fact that since it lies on tangent, you can express beta and alpha in terms of each other, right?
Right.
And as soon as
Yeah.
you put it there, it will become a family of lines from where you can find
Family
the
of
point of
lines.
intersection, right?
Correct.
Okay, so second part of this question is uh, the one second. The points from which the points from which perpendicular tangents can be drawn both to the circle and the parabola.
Mm.
And the parabola.
Well,
So you have some options here. One option is 4 comma plus minus root 3. And the other option is minus 1 comma root 2. And then minus root 2 comma minus root 2. Last option is minus 2 comma plus minus 2. You have to find the points from which you can draw perpendicular tangents both to the circle and the parabola. Is there a particular set of point or some locus from where you can draw perpendicular tangents to a parabola? For circles and all, we know there is a locus, right?
Yeah,
Vector circle, right?
correct.
But for parabola, what is the set of points from where you can draw perpendicular tangents? Or two perpendicular tangents to a parabola will intersect where?
That is the directrix right there.
So from the directrix, you can draw two perpendicular tangents basically.
Yeah,
Why? Because you can take arbitrary point. You have to show that this angle is 90, right? So,
correct.
so point of intersection of tangents is this, right? Correct.
Yeah,
And each tangent equation was like this. So you can say slope of each tangent is 1 by t, right?
1 by t.
So if the slopes of the tangents are perpendicular, 1 by t multiplied by 1 by t1 multiplied by 1 by t2 should be -1. So t1, t2 should be minus.
Minus
If you put t1, t2 -1, this becomes on the directrix, right?
right.
Correct, no?
Yeah,
So if you have to draw perpendicular tangents to this parabola, it has to lie on the directrix, which is x is equal to -2, right?
yeah,
And what are the points which lie on the directrix and also lie on the director circle of this one, right? Director circle would be x square plus y square is equal to 8, right?
8. Yeah,
So when you put -2 here, you will get 4 and y square will become 4.
4.
So y will be plus minus 2, right?
Yeah,
So option D, basically there are two such points.
yeah,
Makes sense, no?
yeah,
You need to remember this thing that from a directrix, if you draw tangents to to a parabola, two tangents, they are always perpendicular.
yeah, perpendicular. Yeah.
Okay. And one last part of this question is uh, locus of locus of circumcenter of triangle AQB if P is 8 comma 8. So AQB, A was what? A and B were ends of chord of contact, right? Were ends of COC. 2
Yeah,
x square plus y square is equal to 4. And P was the point from where you drew the tangent, first of all.
tangents. Yeah,
And Q was alpha beta, from where you drew the chord of contact, right?
yeah.
So now you have to find locus of circumcenter of AQB.
Hmm.
So you have to basically find the circumcenter.
Mm.
If you see carefully here, the quadrilateral AOQB
AQB,
or
yeah,
QBOA, right, is cyclic.
yeah, yeah.
Cyclic because 90 here, 90 here.
19. Mm.
So if it is cyclic, then basically you can say that circumcircle of AQB is that circle, right, which passes through O also.
AQB,
Circumcircle of
yeah, will pass
AQB will
through
be the
O
circle
as
that
well.
passes through O also, right?
Yeah,
Because they are cyclic. And you have to
correct.
find center of that circle, AQB circumcircle.
Yeah,
So if it is cyclic like this, then obviously, since these angles are 90, QO is a diameter, right? Because angle in a semicircle is
yeah,
90.
90, yeah.
So center is the midpoint of Q and O, right?
Midpoint of Q and O.
So your circumcircle center is midpoint of Q and O, right?
Yeah,
And Q was
yeah,
alpha beta. So it is alpha by 2 comma beta by 2 is your
beta by 2.
H comma K, right?
Yeah,
Now, from the previous thing, we remember that T was 8 comma 8. So AT square, A was 2, right? So 2T square comma 280, 40, right?
240, yeah.
Was 8 comma 8. So we know that T is 2, right?
2. Hmm.
And uh, the equation of the tangent was Ty is equal to
Ty
x
is
plus
equal to
2t
x
square.
plus 2t square,
And
yeah.
t is 2. So 2y is equal to x plus 8, right? Correct.
Yeah,
And alpha comma beta lies on this, right?
on that. Hmm.
So we know that 2 beta is equal to alpha plus 8, right?
Correct.
So that just gives us the locus easily. Now you can say
Yeah, just
alpha is 2h, right? And beta is
2h,
2k.
yeah.
So 4k is equal to 2h plus 8.
2h plus 8.
So you get 2k is equal to h plus 4. So x plus 4 is equal to 2y, right?
2i. Hmm.
So that should be your locus of the circumcenter, right?
Right.
So we are using the fact that anytime you have this sort of a situation, a circle is there and a point is there from which two tangents are drawn and you have a chord of contact situation, right?
Hmm.
We
Yeah.
know that this is radius, this is radius, this is 90, this is 90. And we know that all these triangles are congruent. This big one here and
Congruent. Yeah.
everything is congruent here. And obviously cyclic also. PQRS is cyclic quadrilateral because of 90-90. And the center of that circle is midpoint of PR because of what we just saw, right? The PR is a
Yeah.
diameter, right? If you wanted to find the equation of the circle, you would have said x minus xp, x minus xr, plus y minus yp, y minus yr is 0, right? You can write the equation of this circle in diametric form, right?
Yeah.
Correct.
Yeah.
This distance, for example, is root S1 for this circle S1, length of tangent, which is equal to this, right?
Mhm.
So there are many nice properties whenever you have pair of tangents from a point and chord of contact from them. Correct.
Right. Yeah.
So
Yeah.
you have to remember those. Then the next one is this. If the focus of y square plus 8 is equal to 4x coincides with one of the foci of ellipse 3x square plus by square minus 12x is equal to 0, then 1 by e is equal to what? Where e is eccentricity of the ellipse. Focus of this parabola is easy to find for us at least, right?
So, parabola. Yeah. We can just
Y square is equal to 4x minus 2.
4x minus 2.
So 4ax. So a is
A is
1.
1.
You can say focus will be x is equal to a and y is equal to 0, right?
0. Yeah.
So 3 comma 0 is focus, right?
Yeah.
3 comma 0 is the focus of the parabola, and that coincides with one of the foci of this ellipse, right?
Mm-hmm. Yeah.
Okay. This ellipse, let's think about 3x square minus 12x and plus 12 if I do, right? Plus
Mm-hmm.
by square is equal to 12, right? Correct.
Right. Yeah.
I have done plus 12 because I want to make perfect square here. So 3x
Correct.
square minus 4x plus 4, right? X minus 2 whole
Mm.
square plus by square is equal to 12, right?
Yeah.
X minus 2 whole square by 4 plus y square by 12 by b is equal to 1, right?
Correct.
This is my ellipse. Here capital
Ellipse
X is x minus 2, capital Y is y, right?
y square.
A is
Yeah.
equal to 2 and Your b is equal to root over 12 by,
12 by,
we can call this b dash, right?
okay, yeah,
And so your eccentricity right now is, eccentricity is 1 minus b square by a square, right? So 12 by b dash by 4 root
hmm,
over, right? So 1 minus
yeah,
3 by b dash is e, right? Correct.
correct,
And focus will be at capital X is equal to a into e, right?
A into B, yeah,
Focus and y is a 0, right?
hmm,
Focus would be capital X is AE, Y is 0, right?
0,
So X minus
yeah,
2 is equal to A into E. A is 2. E is root over 1 minus 3 by B dash, right? And this focus must match this, right? Correct.
mm, yeah, yeah,
So 2 plus 2 into root of this. You should get 2 plus 2 into root of 1 minus 3 by B dash should be equal to 3. So this becomes 1.
hmm,
And this becomes 1 by 2, right?
1 by 2, yeah,
And that is your eccentricity, correct?
yeah,
So 1 by e is going to be 2, right?
1 by, yeah, 1 by E is 2,
So in general, like this question is about if the form of the curves is not like what you expect, then how do you handle that, right?
how do you solve it, yeah,
So this is obvious how to get the focus in this. In case of the ellipse, we made a perfect square and added a constant term on this side and then got it like this. And then afterward,
right,
it's about matching it to the correct form. Like you took these, right?
yeah,
Obviously, here there are some assumptions here. The assumption here was that this is bigger than this, right?
correct, yeah,
If this is smaller than this, your ellipse is a
smaller than,
ellipse like this, right?
yeah,
With foci on the y-axis, right?
y axis, correct,
And it will be 1 minus a square by b square would have been your eccentricity. But then that
yeah,
would not have fit with the question which says focus is on x-axis, right?
hmm, yeah, yeah,
That would not have fit. That's why we have assumed it and not worried about it. But in general, it's not necessary that always 4 will be greater than this, right?
correct, yeah, hmm,
Okay. Then let's look at this one. Uh, the radius of circle which passes through the focus of x square is equal to 4y and touches it at the point 6 comma 9 is k root 10. Find k. Radius of the circle which passes through the focus of this and touches it at the point this.
hmm, So like the focus is 0, 1.
Focus is 0, 1, correct.
Then
Passes, so you know what about the circle? Circle passes through
focus and
0, 1. It also passes through 6, 9
6, 9.
and tangent at 6, 9 also, right? Tangent at 6, 9 equation you can find, no?
Yeah,
Right?
tangent at 6, 9 will be that
X
6x
to
is equal
6,
to
2 into y plus 9.
2 into y plus 9. Yeah.
So you'll get 3x is equal to y plus 9, right? So basically now you have circle which passes through 0, 1 and is tangent at to the line 3x is equal to y plus 9, right?
Yeah.
Correct. So
So that
now
line is a tangent to the circle, right?
hmm,
At that point.
it
Yeah.
is tangent to both. So it's tangent to the circle at 6, 9, right?
Yeah.
Okay. So this is equation of family of circle. Equation of family of circles given the equation of the tangent. Given tangent equation. So we know that the circle passes through 6, 9 and is tangent to this line, right?
Yeah.
The equation of family of circles in such case is, write it like this: x minus 6 whole square plus y minus 9 whole square. As if you are drawing circle with center 6, 9 plus lambda into the tangent equation, which is y minus 3x plus 9 is equal to 0.
Plus 9 is equal to 0. Yeah. Okay.
Like this is a theory thing that you need to know, that if you are given tangent and point of tangency, tangent line and point of tangency, then this is the family of circles that you
And
can draw.
yeah.
You will notice that if you put 6, 9, this will disappear, the whole thing, because it has
Right.
to pass through 6, 9, right?
6 bar 9. Yeah.
And
Yeah.
this is a equation of a circle because it is 2 degree and all, right?
Correct.
So now how to find lambda? We are given the third point to find lambda. 0, 1 will pass through the circle, right?
Yeah. Focus also.
So you will put 0, 1 here. You will get 36 plus 64 plus lambda into, it will be 10 is equal to 0. So you'll get
0.
lambda is equal
Yeah.
to minus 10, right? And
Yeah.
after that, you
Yeah.
get your equation of the circle. Your equation of the circle becomes x square plus y square. There's a minus 12x and a plus 30x. So plus
Minus.
18x.
Yeah.
And minus 18y and minus 10y. So minus 28y plus 27 is equal to 0. This is my circle equation, and radius is therefore now root over 9 square plus 14 square minus 27.
27.
81 plus 196, and that becomes 4 and 274 and 277 minus 27. So 250. Radius is 250, and that is 25 into 10,
5
so
root
5 root 10.
10.
So answer is K is 5. Right? Correct, no? So this family of circles
Yeah.
stuff, like there are different cases when you need to know what is the equation of family of curves and all. So just go through that. It will be written in your Allen book also in your results and all. Equation of family of
Yeah,
circles given this situation, given the line and stuff, right?
right.
Uh, second. So basically there are three, four cases in that. I can tell you those. I will just summarize for you. So equation of family of circles, if there are two circles given and you have to find family of circles through the point of intersection of two circles. Point of intersection of two circles. What is the family of circles through that? That will simply be S1 plus lambda S2 is 0, right? And lambda cannot be minus 1. Because if lambda is minus 1, that becomes equation of, this is equation of common chord, right? Equation of common chord of this two circle or radical axis will be this. You remember all this? Like if there are two circles, if they intersect, this line is common chord, right? This is S1 minus
Yeah,
S2 is 0. If they don't intersect, this line is called radical axis, where equal tangents can be drawn.
radical. Yeah,
Root S1 is equal to root S2, then it will become S1 is equal to S2, right? This line.
correct.
So therefore, lambda cannot be minus 1 because in those cases, it is the locus is a line, right?
Yeah, cannot be.
Because you will realize that the x square and y square term can be cancelled if lambda is minus 1, right?
Yeah,
So all the other cases when lambda is minus not minus 1, the equation will still remain a circle. And that circle will be the circles that pass through the point of
pass
intersection,
through the point of intersection.
family of circles, right?
Yeah,
Then this is the first case. The second case is locus or family of circles through point of intersection of a circle and a line. Of a circle and a line. Right? In that case, you'll say just S plus KL is equal to 0. Right? Circle
yeah.
equation is S is equal to 0, line equation is L is equal to 0. Right?
L equals. Yeah.
Then third case is locus of family of circles passing through 2 points. Family of circles through 2 points. 2 points are x1, y1 and x2, y2. Okay. So here what you will do is you will first make equation of circle as if x1, y1 and x2, y2 are diameters, diametric points. And then you will say plus k times equation of line between them, line joining them.
Right.
Basically, line joining them equation would be something like this: xy1, x1, y1, 1, x2, y2, 1. This determinant. You can realize that it's just 2-point form.
Yeah, 2.4.
So this is equation of circle as if these are diametric points plus k times equation of line joining them. Okay.
Yeah.
Now, the last case is the case that we just now saw, which is family of circles touching a line at a fixed point, right?
Yeah.
Equation of family touching, let's say touching which line? Y minus y1 is equal to m into x minus x1 at x1 comma y1, right? In that
Yeah.
case, we say x minus x1 whole square plus y minus y1 whole square plus k times this equation.
Yeah.
Okay. So
Yeah. Yeah.
these are the four main cases of family of circles that you need to know. Yeah, one last case is there that if you want to find, if you are given three line equations, L1 is equal to 0, L2 is equal to 0, L3 is equal to 0, which make a triangle,
Mhm.
and you want to find circumcircle equation, circumcircle of triangle made by these three lines, then you
Right.
can just write it like this: L1, L2 plus lambda into L2, L3 plus mu into L3, L1 is equal to 0. And
Right.
in this case, the conditions are that eventually your coefficient of x square and should be equal to coefficient of y square, and coefficient of xy should be 0. Then only it is a circle.
Circle. Yeah.
So you apply those conditions after getting this equation, and that should give you some restrictions on mu and lambda.
On lambda and yeah. Yeah.
So this is not used much, fifth one, because mostly you're not given three line equations and triangle. You will be given some geometrical way to get circumcircle, right?
Mhm.
But if it is,
Yeah.
then this is one thing that you might need very rarely. But the four cases of
Mhm.
family of circles are quite important. Okay. So
Right.
family of circles when circles intersect, family of circles when circle and a line intersects, family of circles passing through two arbitrary points, and family of circles touching a line at a point.
Point. Mhm.
So those four cases you should know. Uh, we'll go on to ellipse and parabola in the next class. Tomorrow we can do that. What times are you free tomorrow? Like what are the class schedule these days? What is happening?
Tomorrow is fine. Class is mainly in the afternoon, like after
Morning
12.
is fine.
Yeah.
Okay. And tests and all are happening every week, no?
Yeah. Every week plus test.
Okay. Okay, fine. So tomorrow we'll continue. Like I want to do maths till the end of Jan, like hopefully finish a good chunk of the revision and then we'll do physics. Dates and all have not yet been announced, right?
No, no, there are no dates yet.
Right now they have not yet released when is first round and stuff.
No.
Okay. Uh, so we'll continue with the plan. We'll finish maths revision this month and then we'll go on to physics.
Yeah. Fine.
So tomorrow we'll continue. We'll do hyperbola, ellipse, some questions. Okay.
Mhm.
I'll see you then. Morning.
Yeah. Okay.
Bye.